Distance formula comes from Pythagorean theorem. Sorry, having some congestion. We're going to start by looking at Pythagorean theorem, which is a squared plus b squared equals c squared. In order to get c, which would be the length of the hypotenuse of a right triangle, we would square root both sides. Taking the square root of both sides would get c by itself, which would be the length of segment C. The distance formula comes from this. Here we have a coordinate grid with the x and y axis, and we have a line segment. We do not know the coordinates for the points on this line segment. So what we're going to do is we're going to use letters and subscript to identify them. This will be x1, y1. And the one up on the top right will be x2, y2. In order to relate this to Pythagorean theorem, I'm going to draw in a triangle, a right triangle. So we would have our horizontal distance and our vertical distance. The horizontal distance is going to be found by looking at the change in the x values. Think of where they would line up on the x-axis. This one's at x1, this is at x2. In order to find the distance between them, we would subtract them. So x2 minus x1 is the way to represent the length of this bottom segment, which when we were doing Pythagorean theorem was represented by the letter A. To look at the vertical distance, you're going to want to think about where these are lining up with the y-axis. The upper one is at y2, the bottom one at y1. This distance would be the difference between those numbers. And that was expressed as the letter B in the Pythagorean theorem. So in order to get the distance along the line segment, which is C, we can replace in the Pythagorean theorem A with x2 minus x1. And we can replace the letter B with y2 minus y1. This will create the distance formula. So our distance is equal to, that's the C is the distance. We don't need to write that part, but it is the square root of our A squared, and A is being represented by x2 minus x1. That represents the change in the x's. And remember that A was squared, so in the distance formula, that difference is squared. So you're going to do the difference first. You're going to square it. Keep in mind that when you square a number, even if it is a negative number, it will become a positive value. The other part of the equation, it has the plus sign in the middle. That Pythagorean theorem was a squared plus b squared, right? So we still have that plus sign. Where the b squared was located in Pythagorean theorem is going to be replaced by the change in the y values. That gives you that vertical length. And then we square that because the Pythagorean theorem was a squared plus b squared. And we square root the whole thing because we don't want a squared plus b squared equals c squared. We want to know what c is by itself. So we want to square root a squared plus b squared. And so Here is our formula in terms of the coordinate grid, in terms of our points as though they are written with x1, y1 and x2, y2. You will be using the coordinates from the actual points and plugging those in for your x2 and your x1 and your y2 and your y1. Then you will simplify, and you will usually write your answer as a simplest radical form. In the notes here, we are going to do exact form as well as a rounded form. I'm going to grab a calculator real quick. Because I certainly can't do a nearest tenth of a square root without a calculator. So we are using this picture. We have a triangle ABC, and we're going to use the distance formula in order to find the distance between the points. If you have it on a coordinate grid, know that you could potentially draw in a right triangle that would be connecting them. I like to call it like a slope step, like the slope from A to B. You'd have like your rise and your run. And it makes a right triangle. And you're welcome to do Pythagorean theorem to find the answer. But I'm going to practice with the distance formula. There's times that we'll want to use the distance formula rather than this Pythagorean theorem. Like maybe the points are too far apart to be graphing, or we don't have graph paper or something like that. So in order to find the length of AB, I'm going to need to know what coordinate point A is located at. So remember that the points have the x first and then the y, and the x value for A is at -2. The y value is at 3. For B is at x value 2, y value 5. So for the formula, this is my x1, y1, x2, y2, and we're going to plug into the distance formula. So I'm going to do some highlighting just to show you where things are going to go. My x2 will go first there. That'll be this, 2. Then my x1. And that will be this x. And it doesn't matter which one is x1 and which one is x2 as long as like point A has x1 and y1, or it could be x2, y2. You don't want to mix together the 1s and the 2s in the same point. Now for the y's, we have y2. So that will be our y2. And we have y1. And that will be y1. So we're just going to fill in and simplify. The hardest part about this is remembering the formula. So practice the formula. Think about where it comes from Pythagorean theorem. You can always try to use Pythagorean theorem as a backup if you are struggling to use the actual formula. So we're going to square root. We want to start with our x2, which was 2, minus our x1, which was a -2. We're going to square that, plus our change in y's. So it's going to be y2, which is 5, minus y1, which is 3, in parentheses squared. And we need to simplify. So first thing, we don't want to just go put this in the calculator because that will not give us the simplest radical form. And when you have minus a minus, you're going to end up adding. That's going to be 4 squared. 5 minus 3 is 2, so 2 squared there. This is going to be the square root of 16 and 4, which is the square root of 20. And since we want an exact form answer, we need to think about the simplest radical form for the square root of 20. I like to use the factor tree method of simplification, which means I think about how the factorization of 20 would go. You could say 4 times 5, you could say 2 times 10, you can start the breakdown any way you want. Then continue breaking these down until you have the prime factorization, which means that the ends of each piece is a prime number. Then you look for pairs. The pair goes out as 1, lonelies stay home, that's what I like to say. The reason this works is that the pair of 2's comes from the 4. And we know the square root of 4. The square root of 4 is 2. Therefore, when you're thinking about how the square root of 20 can be rewritten as the square root of 4 times the square root of 5, well, the square root of 4 becomes 2. The 5 cannot simplify. It is stuck inside of the root. So the pair of 2's gets out. The lonely 5 stays home. That's just easy for me to remember. That is the exact answer. So this is the length of AB as an exact answer. Now, they also wanted the approximate answer. So AB, do a squiggly equals because we are rounding. And when we are rounding, the square root of 20 to the nearest tenth would be, it's 4.472135, so 4.5. We are rounding to the tenths place. That is the approximate length for AB. Let's look at another one together. If we are looking at BC, so looking at BC here, so there's a pair of X and Y. Need to label C. C is at 5, 1. And I'm going to write these down over here where BC is. So B, 2, 5, C, 5, 1. I'm going to zoom in. I'm going to call this my X1, Y1, my X2, my Y2, and I'm going to fill that into the distance formula. Distance formula is X2, well, that's my 5, minus my X1, that's my change in my X's squared, plus the change in my Y's squared, which is going to be 1 minus 5. And then we're going to square root that whole thing. So we're going to simplify this. 5 minus 2 is 3. 3 squared is 9. 1 minus 5 is negative 4. And negative 4 squared is positive 16. Make sure you're getting that positive value there. Negative 4 squared, positive 16. 9 plus 16 is going to give me 25. Square root of 25. Don't leave your square root symbol behind. That's another common error. And the square root of 25 is 5, exactly. So in this case, the length of, what is this, BC? It's exactly 5. Now, they did say to approximate to the nearest tenth. And when they say that, we do want you to think, where would this be to the tens place? And I know it seems really, really silly, but it's a whole number. And if I'm rounding this whole number to the tens place, then you need to tell me that the tens place would be 0. That makes it even more accurate than just saying 5 as the answer. Because if I see an answer of 5 and I don't have context behind it, then I don't know, like, was it 5.1, 5.2, 4.9? But we can round it to the nearest tenth and say it's 5.0. And that just really gives me even more information. So if they ever say, write your answer to the nearest tenth, make sure that you put the tenths place, even if that tenths place is the value 0. All right, now, it would be a good idea for you to pause the video at this time and try to find the length of AC on your own. And then once you have completed finding the length of AC, push play again and see if you got the same answer that I did. So if you are working the notes at home and want to do that, go ahead and pause now. And hopefully you tried to find the length of AC. So I'm going to run through finding the length of AC real quick. So A is at -2, 3, C is at 5, 1, and zooming in, this will be X1, Y1, X2, Y2, square root, should have had 5 minus -2 squared, plus 1 minus 3 squared, minus and minus will be adding, that'll be 5 and 2 is 7, 7 squared is 49, 1 minus 3 is negative 2. Negative 2 squared is positive 4. Square root of this will be 53. 53, I don't know if that divides by anything. If you're struggling to figure out what things divide by, in your calculator you can push the y equals and you can type the number. So here 53 divided by x, and then go to the table and see if anything gives you whole numbers. It appears as though 53 is prime. So for this question, the answer in exact form would be the square root of 53. And the approximate version of the answer, just typing in my calculator, the square root of 53, 7.2801, so 7.3. So that is how we use the distance formula. Now there is an add-on to this, and that is what is the perimeter of triangle ABC in exact form and approximated to the nearest tenth. And this is good for us to talk about how we would use radical form and simplify. So this is separate from what we are about to do, but if I, for example, had 2 root 3 plus 4 plus 5 root 3 plus 6 root 2. If I was trying to simplify this, you can combine like terms. And like terms, when you're using expressions that have radicals in them, the root part needs to have the same value. So root 3, we had 2 root 3's. You are able to combine them. Think on if you had 2x and 5x, you would have 7x's. It's the same idea with root 3's. Here we have 2 and we have 5 more. We have 7 root 3's. We had a whole number, 4. 4 is the only whole number. You would typically put that first. So 4 plus, we're just simplifying essentially. And then 6 root 2 does not have a like term, so it would be just 6 root 2. So this is how you simplify expressions that involve square roots. You combine what you're able to combine, and if you can't combine it, you just write it. It looks like an equation. I'm adding a note here. So this was an example of simplifying a radical expression. Now we're going to simplify the actual triangle's perimeter. So the perimeter of a triangle is found by adding the segments AB plus BC plus AC. And so the length of AB was 2 root 5, the length of BC is 5, and the length of AC is the square root of 53. None of these are able to simplify. So essentially, this is the answer in exact form. Nothing can be combined. It looks like a math equation, but that's just what happens. So right now, I am adding together the pieces here. I'm not adding the rounded answers because, sometimes when you're adding first, it might affect the rounding on that. So I type this into the calculator, 2 root 5 plus root 53, and we want the to the nearest tenth. It's 16.7522, so the 5 would round the 7 up, so it's going to be 16.8. So this is the exact form, and this is the nearest tenth. I'm going to do midpoint in a separate video just in case sometimes people are like, what's midpoint or what's distance? And then you can find the video that is specific to that topic.